SV Math Teach back one more time, this time with linear programming. Now, linear programming normally falls in the systems of equation or systems of inequality lessons. And I have one example because to try and teach them all is frankly unreasonable. But what I am going to do is give you some guidance. Many teachers like setting up some sort of a table. They'll set up a table that is often bigger than it needs to be. That's okay. It just kind of encompasses everything. It'll be 4 columns by, 4 or 5 rows, whatever it takes. You see mine here. The variables will normally go on the left. How many of whatever you want to find, or how much of what you want to find, or what is the value of what you want to find goes on the left-hand side here. In this example, we're going to be looking for the number of t-shirts and the number of sweatshirts of a particular thing. The 2 variables that impact those numbers of t-shirts and sweatshirts go across the top. So time is one constraint, money is another constraint, and then profit is, well, usually one of the objectives of linear functions, of this linear programming is to maximize or minimize either the profit or your costs. It's almost like a business model. So what I have up here at the top is a sample. Now I'm going to try to fill it in and show you how this works. It's time consuming, so I've done much of it in advance. So question 1, in fact, only question. You are screen printing t-shirts and sweatshirts to sell for a fundraiser and are working with the following constraints. Constraints are the things that you have to work within. So you have at most 20 hours to work. Okay, so I'm just kind of note that. You want to spend no more than $600. Okay, so we have to pay some money to make these materials. You want to have at least 50 items to sell. T-shirts take 10 minutes and $4 to make and are sold for $6. Sweatshirts take 30 minutes and $20 and are sold for $20. There's a typo here. This should be 30. It wouldn't make any sense to sell them and make them for the same cost. How many t-shirts and how many sweatshirts should you make to maximize your profit? And what is that maximum profit, right? So there's a maximum amount of money that you can make on this scenario, and how many of each item do you need to sell to maximize your profit? So let's go ahead and see what we can do here. The first thing that I observe is this third item that says you want to have at least 50 items to sell. So between the t-shirts that you have and the sweatshirts that you want to have at least, so greater than or equal to 50 items, right? So T plus S is 50. You could, is greater than or equal to 50. You could use X and Y if you chose. I'm just using things that represent the variables a little bit easier. The next thing I have, t-shirts take 10, okay, so check this out. T-shirts take 10 minutes. So for every t-shirt, takes 10 minutes, right? So 10 times the number of t-shirts. That would be in minutes. If you want to do it in hours, 1/6 T would be the same thing. And $4 to make. So every T is $4. So 4T over here. And are sold for $6. So the profit is 6T. Now, you might argue that the profit is the difference between what it costs and what you bring in. And that would be profit. That's not really what the problem means here. They're trying to make the maximum you bring in is going to generate the maximum profit. The number that we ultimately create from profit is not really the profit. We would have to subtract away our costs. Last bullet. Sweatshirts take 30 minutes, so 30T, right? 30S. And S isn't a very nice variable, but we're going to use it for now anyway. That's also the same as 30 minutes is half an hour, so half of an hour. For each sweatshirt, and $20 to make, so 20S. Notice I'm just trying to organize my information. I've done the 30 minutes, I've done the $20. They sell for $30, so 30S. Now let's see what else we have. We have at most 20 hours to work, so the amount of time I have to invest. Now look at this. I listed time as minutes and hours. And then this problem is listing it in hours. So either I could convert everything into minutes, or I could just leave it as hours. I'm going to go ahead and probably convert it into hours. So let's go ahead and take the 1/6. So watch this. This is how much time it takes to make a t-shirt. This is how much time it takes to make a sweatshirt. If I put those times together, we have to have at most 20. At most 20 means less than or equal to 20. So that's one of my functions. Or one of my inequalities, sorry. And the second bullet point here, you want to spend no more than $600. So from this column, we know that the cost of a t-shirt and the cost of a sweatshirt has to be no more than, so again, less than or equal to $600. So now we have 3 things that we're working with. We have this constraint, which is time, this constraint, which is money, this constraint, which is how many items we have to sell. And we also have a couple real basic ones as well. T has to be greater than or equal to 100. We're not going to make negative t-shirts, and we're not going to make negative sweatshirts. We don't normally worry about those, but if you ever find yourself having to list out all the constraints, you got to list those as well. The final piece I'm going to do is I'm going to take these two statements together and make a profit statement. So the profit, based on the number of t-shirts and the number of sweatshirts, is take the number of t-shirts and multiply it by 6 and add the number of sweatshirts multiplied by 30. Now once again, that's not really profit. We would have to subtract away the cost, but we're going to go ahead and use that as our income. Maybe we should use income as a word instead of profit. Write your constraints, write your objective profit function. So the profit function we've already done. The constraints are highlighted here at the top. So to save some time, I'm not going to rewrite them, and it's going to get a little messy if I start doing all of that. So those are your constraints and your objective or profit function. Graph the constraints to find the feasible region. Now I did start setting this up to show it to you, but what I found was, one, my video is going to run long, and two, it's very common that your graphs don't fit on whatever you first start out with. I thought that this was completely reasonable to fit everything, but it turns out it wasn't, and it would take me 5 more minutes to show it all. So instead, I'm going to graph the constraints using Desmos, D-E-S-M-O-S, Desmos. I'll show that to you in a second, and we'll finish the problem from here. Determine which point maximizes the objective function, so which one or which ones give us the maximum profit. So check it out. I graphed all of these. Now first off, you'll notice that I had 3 constraints, not 5, because I knew that the last 2 constraints, the x and the y, or the s and the t, have to be greater than or equal to 0. That's just going to keep me in quadrant 1. So I'm just going to kind of ignore everything that's not in quadrant 1. But I solved everything for one of my variables. I substituted x and y. And here's what I find. I have this inequality, and I have a line here I'm going to draw. I have this inequality where everything overlaps. It goes from here, down to here, down to here, down to here. That region right there, that region is the region of combinations of t-shirts and sweatshirts that are feasible, that we're allowed to create. Our maximum and minimum is going to be on these corners. One of these corners, or maybe more than one corner, will produce the maximum amount of money we can create from this, and one or more of these corners will create the minimum number. The stuff that's inside the shaded region, but not on the vertices of the shape, those are going to be ones that are kind of in between your max and min. So they're all feasible, they're all reasonable, and they're likely as well. But the corners or the vertices are the ones you really want to test. Okay? So I've graphed it, and then here's what I do. I use my objective function, and I substitute in each of the vertices. I wrote my vertices in white. So 25, 25, 50 and 0, 75 and 15, and 120 and 0 are my 4 corners. In Desmos, you can find that just by tapping on the 2 lines where they touch. Pretty nice. And I put each one of those, let's get off of yellow here, 25, 25, 50 and 0, 75, 15, and 120 and 0. I put them all in for T and S, and I found that I had 2 highest numbers. So that means I have 2 maximum options. Either one of them will produce my maximum profit, and though this question doesn't ask for it, I do have a minimum as well. So my minimum amount of profit would be the 300. Okay? That's it. So linear programming is really all about, it's long, it's really all about reading the question really carefully, trying to either set up a table or just take the information that's offered and write it down in algebraic form. You're going to take those things you've written that are called constraints, and you're going to graph them. You can graph them by hand. You can use some technology to help you graph as well. From the graph, you're going to look for your corners. Sometimes you'll have 3 or 4 or even 5 corners or vertices. You look for those vertices. You identify what those x and y values are. Get those associated with your variables inside of the problem. You then test those against your objective function that you hopefully wrote already, and from there you can find max and min.